So stoichiometry is a big scary word, but it's actually not that difficult, especially if you've already learned, like we have, how to do the factor label method with the tic-tac-toe board. That's all kind of this what this rests on. So as long as you understand that, and that when you want to cross something out, it goes opposite, this shouldn't be too bad. One of the keys here, one of the key things with stoichiometry is this mole to mole ratio. So it's going to be different than anything we've done before, is you're actually going to be given a balanced chemical equation, and you're going to have to change substances. Every molar conversion that we've done before, you've converted within the same substance. Now you're going to change substances, and the way you do that is a mole to mole conversion. It is moles over moles. That is the way you trade places with something. Think of it kind of like a train station, like a hub, or if you're changing planes, this is where you change over from substance A to substance B. So this little chart here can help you figure out, this path. The nice thing about stoichiometry is it follows the same path. The rules are always the same. So on this left side is what you're starting out with. You could be given a number with any one of these units, grams, liters, molecules. You can even start with moles. The goal is whatever unit you start with to get that into moles. You have to have it into moles. So if you start in grams, you start in liters, you start in molecules, your first step is to turn that to moles. As soon as you get to moles, your next step is always to change substances now. After the mole comes the mole conversion. The thing that's going to be different with the mole conversion is instead of your normal 1 mole that you've been using, you're going to use the coefficients from the balanced equation. That's why you need that equation. When you're done that, you're going to be in moles, so then sometimes the problem's going to ask you to put it back into grams, liters, or molecules. The nice thing is it's going to follow that pattern. Whatever you're starting with, turn it to moles, do a mole to mole ratio to change substances using the coefficients, and then turn it out into whatever unit that specific problem is asking for. So if we start with number 34 here, it says, what volume of NH3 at STP, I like to make little notes for myself, so I'm going to put question mark liters because that measures volume, is produced if you have 25 grams of N2. So again, I just find it helpful to make little notations. This is what I want you to notice. 25 grams is what I'm given, and it's asking for liters, but not liters of N2, liters of NH3. You have to change substances with stoich. Most of the other stuff with the tic-tac-toe board is the same. You start with what you're given, the 25 grams of N2. You make your tic-tac-toe board. And if you remember from the thing we just looked at, if you're starting in grams, your first step is always to go from grams to moles. If grams is here and I want to get rid of it, you're going to go opposite. Cross out the grams. You're going to go grams to moles. So you're going to do 1 mole of N2. You have not changed substances yet. You're still in the N2. And remember I said before, the molar mass that goes here with the grams should match what it's paired with. So because N2 is on the top, you're going to put the molar mass of N2, which is 28.02 on the bottom. Now you're in moles. As soon as you're in moles, your next step is always the mole to mole conversion. You're doing the same unit, moles over moles. To know what to put on the bottom, that's why you put N2. If you need to get rid of N2 and turn it to NH3, you need to put moles of N2 opposite. Same rule, when something goes opposite something else, it cancels out. Now you put the substance you're looking for, NH3, on the top. That's why I make those little notations at the beginning, because it's easy for me to look and see that I'm trying to turn it into NH3. Now, with this mole to mole conversion, you're used to putting 1 mole every time, 1 mole, 1 mole. You still follow that when you're converting within the same substance, but as soon as you hit this mole to mole conversion, the mole amounts come from the balanced equation. That's why that's there. The equations will be balanced for you. So I'm going to look and see that the coefficient with NH3 is a 2. The coefficient with N2 is a 1. Remember, it's nothing written there, it's a 1. Now, if you notice, right at this moment, I'm in moles of NH3. That's what unit I would be in if I stopped. The question is asking for liters, so I'm going to do a simple mole to liter conversion with moles on the bottom, 22.4 liters on the top. And then again with your mass, same thing as we've been doing. You have 2 choices. You can multiply the top, multiply the bottom, and divide. So you can do 25 times 1 times 2 times 22.4, and then 28.02 times 1 times 1 and divide. Or, again, whenever you multiply or divide by the 1, it doesn't really do anything. So you can do 25 divided by 28.02 times 2 times 22.4. Either way, the answer you should be getting is 39.97 liters of NH3. You don't have to put the NH3, but it might be good, especially because you're changing substances. So it's going on to 35. It says if you have 5 grams of KClO3, what volume of O2, remember volume is measured in liters, is produced. So same rules every time. Start with what I'm given. 5 grams of KClO3. Make my little board here. I'm starting in grams. First step is I need to get it to moles. So I'm going to use the molar mass of KClO3. Grams goes on the bottom so you can cancel out. The molar mass of KClO3 is 122.55. Now I'm in moles. My next step is a mole to mole conversion. I know that KClO3 goes on the bottom, so I can cancel it out. What I'm looking for, in this case, O2 goes on the top. Coefficients always go in the mole to mole conversion. So there's a 3 in front of the O2, a 2 in front of the KClO3. And then the problem saying it wants the answer, the final answer in liters. Right now I'm in moles, so I just do very simply 1 mole on the bottom, 22.4 liters on the top. That's my normal conversion. Now one note here, if you're doing the kind of as you go type of way, you would do 5 divided by 122.55. Here, because you don't have a 1, treat it like a fraction. Plug it in as 3 over 2. Or, again, you can still do the multiply the top, multiply the bottom, and divide. But you should be getting 1.37 liters of O2. Okay? Nice thing that you should start to see is they're all the same. They always have the same pattern. So this says what volume of hydrogen is produced from 2.5 grams of zinc. This excess of hydrochloric acid thing, that's just meant to distract you. We're going to talk about limiting reactants and excess reactants in the next video, but that's just there to distract you right now. So you're starting with what you're given, 2.5 grams of zinc. I'm in grams. I need to go to moles by dividing by the molar mass of zinc. Remember, they should match. So if I have zinc up here, I should have the molar mass of zinc at the bottom, which is 65.38. Now I'm in moles. My next step is always a mole to mole conversion. Moles of zinc goes on the bottom, so I can cross it out. What I'm looking for, H2, goes on the top. Now I put my coefficients. They just so happen for this one to both be 1s. And then I see from my question that it wants, again, the final answer to be in liters, volume. So I'm going to do 1 mole on the bottom, 22.4 liters on the top, and I should get 0.86 liters of H2. I hope you're recognizing a pattern. I hope you're seeing it's always this, then this, then this. Okay, one last one, a little bit, changing it up a little bit. How many molecules of water? So now I'm asking for question mark molecules. And then it says, are produced if you have 2 grams of sodium sulfate. Now here could be an issue. If you don't know what sodium sulfate is, if you don't remember your formulas, you might know, is it NaOH or is it Na2SO4? It is Na2SO4. So you might have to kind of go back and review a little bit some of your formulas so that you know which one to pick. So sodium sulfate is Na2SO4. So again, I'm going to start with 2 grams of Na2SO4. I'm in grams. My first step is always to go from grams to moles. So I have moles of Na2SO4 on the top, molar mass of Na2SO4 on the bottom. Cross out your grams. As soon as I'm in moles, the next step is always a mole to mole conversion. Na2SO4 goes on the bottom. What I'm looking for, H2O, goes on the top. Cross out the Na2SO4. I'm going to use my coefficient, so this time it's going to be 2/1. And then this time it wants the answer in molecules, so a little bit different. Same principle though. 1 mole goes on the bottom. 6.02 times 10 to the 23rd molecules on the top. Go ahead and plug that in your calculator, and your answer should be 6.77 times 10 to the 22nd molecules of H2O. Make sure you box off your answer.